Let's look at another example of vertex form. This time we're going to see a parabola that opens downward. We clock from the very beginning the presence of the -1/2, which is an indication that the graph is going to open downward instead of upward. We use the vertex form to quickly identify the vertex. Well, the 2 indicates that we're going to move 2 units to the right because of the minus sign. The 8 indicates that we're going to move 8 units up. So we should expect our vertex to be at the point 2, 8, right here. We also know, because the axis of symmetry will always go through the vertex, that I can draw my axis of symmetry on the vertical line x is equal to 2. Let's find our y-intercept and our x-intercepts in an effort to produce the graph of this quadratic function. So we start first by letting x equal 0. That's going to give us our y-intercept, so -1/2, 0 minus 2 squared plus 8. Y equals -1/2. This is equal to 4 plus 8, and altogether we get 6, meaning our y-intercept will be at the point 0, 6, which makes sense with what we anticipated. We anticipated the parabola was going to open downward, and the mathematics and the arithmetic that we did bears that out. So we know we have a y-intercept at 0, 6, and we also are going to have its reflection point 2 units over on the other side. Here's its reflection point at 4, 6. We're 3/5 of the way there for the points that we always like to have when graphing a parabola. Now let's find our x-intercepts. So we go back to our original function, let y equal 0. Again, the presence of that square around the expression x minus 2 suggests that the square root method would be a good route to go, since we're going to easily sort of knock out the other term or the other constants and be left with that square root. You can check my arithmetic on this, but isolating that square, we get x is equal to x minus 2 squared. Taking the square root of both sides, we're left with x minus 2, and on the left-hand side, we have both roots, the plus and minus 4. Add 2 over, and here's that symmetry again. 2 is the place where we expected the axis of symmetry to be, and then we're going to go 4 units to the right of 2 and 4 units to the left of 2. If you end up with an expression that does not have you sort of moving around the axis of symmetry, you've done something wrong. That's the number that you want to see there, so that you can go 4 units to the right and end up at the point 6, 0, and you want to go 4 units to the left so that you can end up at -2, 0. Getting our nice rounded parabola shape through the vertex, we try as best as we can to draw it through all of those points that are on both the left and the right of the axis of symmetry. We originally clocked at the beginning that this parabola was going to open down. All of our arithmetic and algebra bore that out. Our intercept was in a place that it was supposed to be. Our y-intercept was in a place that it was supposed to be, and so were the x-intercepts. Seeing that symmetry between the x-intercepts and the axis of symmetry.